Em nói thì em phải trước nói nghe nó là cái không phải tôi được
Good afternoon, teacher, and good afternoon, class. I'm Nguyễn Hương Thảo, and I'm the leader of Group 5. Our group consists of three people, my friend Nguyễn Thị Anh Thơ and Nguyễn Thành Nam. It is my honor to be here to represent for you our assignment. The topic name is IoT-based smoke detection and fire alert system. We're gonna introduce about it part by part. The first one is user requirements.
So about the user requirements, we have several general informations. The first one is our product name is IoT-based smart clock, and its functions include display time, specifically our minute and second, date, also day, month, year, temperature, and humidity, and some notable features are fire detections and alarm, and it can send alerts to mobile phones when kind of like there's fire risk. So the detailed description is that it functions as a regular clock, like it's still a clock, but it has with some like added environmental monitoring, and it will trigger an alarm and phone notifications when temperature exceeds kind of like a safe levels. So some of the reasons why we came to kind of like decided to make this products is because of the current situations. We have conducted some research and found out that in 2024 there are more than 4,000 fires nationwide in Vietnam, and like about 1/4 of them are in residential and mixed use house, and it results in more than 100 deaths and more than 70 injuries. So we want to kind of like have something to kind of like can help, like just a little part is okay, help decrease the injuries and the death caused by the fires. And of course there are a lot of like the users, a lot of users can use our product, but we specifically target office worker. And so our kind of like product is kind of like a compact, accurate clock displaying time, temperature, and humidity, but it's also have some kind of like real-time fire warnings. Our specifications are again the functions. There are 5 main ones. It can display real-time. It's measure and display room temperature and humidity. It detects smoke and gas presence, and it can also send an alert to the phone. And it has like flash, LED, and or buzzer when detect a gas or smoke. Here's some pictures of our products. As you guys can see here, it can clearly display the time, like functions as a normal clock as well, the temperatures and the humidity, but it's also can send a warning, like in the pictures on the right hand, it can send a warning like gas warning with the level, kind of like note here. Okay. So how about some non-functions? You can update the information once per like 1 to 2 seconds. It has high accuracy because the time deviation is the whole year. It's just about like less than 2 minutes. And this can operate within the humidity range of like 0 to 100 RH with the accuracy of like around 2 to 5%. And the temperature range from like minus 40 degrees to around 80 degrees with kind of like the accuracy ranging about around that, like 0.5 Celsius degree. And it It had kind of some like detections to action delays pretty minimal because the time from the temperature threshold reach to alert sound and phone notifications is less than 5 seconds. It's clear, of course, clear, very clear, easy to read, and it has kind of like an intuitive interface.
About design, in a system controller either we have three inputs data. First is temperature and humidity sensor. It get humidity and temperature to system controller, and the next one is RTC clock input to get time, and gas sensor to evaluate the gas level, and then three kind of data, and then put into system controller. After that, is put into app via cloud and also display in screen. And if the gas level get over a level, then the buzzer will active. And next is detail of each block. The first is my group will choose system controller is ASP 32 with the main feature here you can see on the slide, with CPU, memory, wireless connectivity, integrated Wi-Fi and Bluetooth, and the power consumption is about 3.3 volt to 5 volt, and with many communication. Next is the humidity and temperature sensor is the HT22, with a temper range is from -40 degrees to 80 degrees, and the accuracy is about -0.5, and humidity will range from 0 HR to 100 HR, and power usage from 3 to 5.5 volt, and the sampling reading is 0.5 hertz. This means that the sensor will read 2 seconds on reading. Next is RTC EDS hertz 3231. Is well, timekeeping is hour, minute, second, day, date, month, year, day of the week, and the accuracy is 2 ppm if the range temperature is 0 to 40 degrees. And next is smoke sensor is MQ2. It can be detected LPG, propane, methanol, alcohol, and smoke. With detection range is from to 200 ppm and to 10,000 ppm. And next is LCD to display the data from the three sensor. And buzzer, here is the features. And also we decided to use Blink IoT. It's designed for the Internet of Things. It can control hardware remotely, and it can display sensor data. It can store data and also visualize it and do many other things. Here is the interface of apps Blink. Here is the temperature and humidity, also time, hour, and minutes. And after we choose the component, and here is a detailed port design. And
the electric incentive, you can take a look. So about the algorithm design, we have designed this algorithm for state to check it for different conditions. The first one is the fire alert, which our clock will display alert and send notifications to our phone when the smoke is the gas level is higher than 3,000 ppm and the temperature is higher than 35.5 Celsius degree. And the second state is to check the overheat. Okay. This algorithm we designed to use for state, like the same algorithm, but the difference is in the checking temperature and gas conditions. The first condition is the fire alert conditions, which is that I have just said, and the second is the overheat, which will send display notifications and send to my phone when the temperature reach more than 35.5 Celsius degree. The third one is the gas alert when the gas is higher than 3,000. And the last one is the gas warning when the gas is higher than 2,000 ppm. This is the result of our implementations. As you can see in the table, this is our product, and the result is displayed here. I've screenshotted in my computer. It can display the time, the date, the humidity level, and the gas sensor value. About the testing, we have done 2 test scenarios. The first one is to test the Wi-Fi connectivity, and I've connected it to my Wi-Fi at home, and it measures that this clock is well active in from 1 to 15 meters. The second test we've taken is the smoke warning and alert test. We focus on the functions of detecting the smoke as the topic. And you can take a look at the table that in all trials it passed. Also in the second trial, it not send the emails into my phone, but it send it via the apps, so it's okay. About the summary of our project, until this time, our project has reached some results. It can accurate operation with fast response to smoke, and it's real-time display of time, temperature, and humidity. It is multi-channel alert system, and the cloud communication enables remote monitoring suitable for boarding house and office, private home. The modular designs allows for easy expansions and maintenance. Also, it still has some disadvantages that the product is currently a prototype on a breadboard, as you can see. So it is not yet fully enclosed, and it is fully dependent on Wi-Fi connections, and no alerts are sent if the network is lost. So I have to connect to the Wi-Fi all the time. And it's only support connection to a single fixed Wi-Fi. In the future, we aim to design a package. We aim to design and package the product into a protective case for long-term use, and we want to add support or selecting and storing multiple Wi-Fi networks. We also want to add the others functions like alarm, and this is all about our presentations and our product. Thank you for listening. If you all have any questions, please willing to ask.
Okay, I think let's say I have some question for you. So each person should answer one question. I want to ask you now. Okay.
Yes.
The question is please explain for me the protocol to the data exchange from MCU with the cloud. So I think can you find the slides of the structure of the system? What is that? The structure, yeah, this one. So you see that you have a MCU very something with the link. I pay attention. One group pay my attention. So if you are difficult for you can ask some this guy was a friend. But furthermore, listen to the question. Okay. Listen to the question. You get right or trying to understand. My question is explain for me the connection between the PP and the event with the black cloud.
H.
The ESP32, that's the IC with the black cloud. That is that cloud. So you are upload data to the cloud. This question is clear. Is clear? Sure. Clear, right? Yeah, the connection. Also, how you can connect it to the from the EPS 32 to the cloud. Okay. And is a root tower, okay. And for the and yes. So the same question is starting from the right now with the right now. Yes. Let's say I change. So so let's say one question is explain from the black cloud to the black. That's not question. That's the lot. You understand? Yes. My question is how do you understand? Yes. Understand. Yes. Okay. So, so we can discuss together. This is really good, okay? And the final question for what will be connection from India to the yeah, that is kind of funny. And the question now. So you have a sense of like EV, and one is the S, one was things like that. Yes, this and one M2. M32 means to detect gas. So my question is, this information and where is the where located the where located, yeah, so where is IDC when are the IDC in place? Or when shooting the IDC convert oxygen to the it's you understand the question. So it clear? Yes. Okay. Okay. Okay, to answer my question. So it's just everybody clear? Okay. So if you are ready, so you can answer my question. So you are, yeah. So if each student sit down and answer any stage from person to person. And then you got my question, right?
Yes.
Okay.
My question is how can the ESP connected to the Blink cloud? And the ESP will send a TCP through the Wi-Fi network to the Blink server, the TCP package through Wi-Fi network to the Blink server, and in the server it will decide which blink by the authenticate tokens that I've added in the code to the ESP.
What you mean is the TCP packet? TCP packet. What do you mean with the TCP packet? It binds the Wi-Fi connection, right? Yes. So it sent the TCP packet, right? So what do you mean with the TCP packet?
Can I prefer the answer?
Yes, please.
So basically, the data will be kind of like segmented when we transfer over a network. Kind of like wireless network is also the same. The data will be segmented, and kind of like the TCP is a protocol. It's used to kind of like in the transport layer, used to like help the packet travel over the internet into kind of like a destination IP. Here is the IP of the server, and the server will based on that using the authenticate token to kind of like pinpoint what clients send the data, and it will kind of like respond to the client. So it's basically what we kind of we want to say.
So can you more answer the question? Yeah. Please, how about the connection between the black cloud to the black cloud? That's all right.
Yeah. So this is on the sorry, on the Blink cloud. So after receiving the packets about the kind of like the humidity, the temperatures and stuff from the from our products, and it will kind of like get that information in the server, and the server will kind of like forward that information into the Blink app. Here is an interface, right? So it will kind of like forward that information in form of packet again. It's travel as the TCP packet once again, and it's also sent over HTTP to our Blink app interface, where it will kind of like use the information sent and display all the kind of like visualize all the data that is being sent. That's my answer.
My question is how SSB behind can get ADC. So the SSB behind can reach analog values using its ADC. It means analog to digital converter, and it's convert analog voltage into digital value.
It's located in the sensor or
it's located in MQ2 because the sensor here can only
answer again the question. Can you say again the answer? Can you repeat again the answer? Where it's located?
The ADC located in MQ2 sensor. Nó là analog.
For sure. So can you have
On MCUs, in the ESP.
in the
ASP
ESP?
has to ASP 32 has two ADC, and HADC has multiple channels, and
So I think let's concentrate on the answer and my question. So I got asked about the ADC, right? So the answer is located in ESP 32, right?
yes,
That's clear. Okay? No need to
explain. Yes,
the question is, it function or no? The whole sensor. So the ADC function, the ADC converter or the whole sensor channel, or it work parallel, or how does it work? I mean, you have three sensor, you have three or two sensor.
Two.
How many two sensor? So it works independently, or it's connected, or it connect all sensor together and then it forms IDC. You get my point? So the IDC form in the ASP 32, that's fine. Yeah. But how it form, because you have a two sensor. So normally we expect that we have a two IDC. But in the design, how many IDC do you use? Do you understand my question? Yes or no? So it's clear. Can you answer my question?
we need time to discuss.
Some time to.
It's my question is on the hardware structure. Yeah. So do you use how many ADC do you use? One. So it works for all sensor, right? Yes or no?
Yes,
Yes or no?
yes,
Yes.
yes.
Yes. So how many bit per sample? How many per sample? Understand that? Yeah. Tại vì cho con thành thành của ADC còn kết nối với cái ADC nó mang định của resolution của nó cái đấy em xem ở đâu một cái máy
thì mới cần một cái tục đã
Việt Nam hỏi cho để Cần như sự chuyển vô đâu I think you can let's say try to understand the work. Okay, that's fine. You can assimilate them. You can put it on team. Yeah, it's fine. So we combine next group. It's a working, right? It's a working, right? Okay, it's working. Okay, that's fine.
We kind of clarify some things before we say that we want to
Is that okay? That's fine. That is a very specific question. So let me start to application. I think you can try. You can find. Okay, in your the it should be there, right? That's how we do application. No problem. That's not trying to. Yeah, try. Yeah. This is the SC in RTC. Yeah, no, let me do it. Yes. Of trouble. Oh, trouble. Này, không. Gắt là gì rồi? Gắt. Đầu gắt rồi. Làm sao thì nhìn thấy được? Khi mà cái gam này nó có kêu không? Nếu thì cho nó còn nó kêu cũng ok cho điểm, còn nếu không kêu thì vẫn không cho điểm, đúng không? Mạnh đều thôi, mạnh hỏng nó nó vẫn chưa đạt đến mức độ
đây là báo cháy có thể nhận ra
level thì nó mới nhận. Thực ra là các quản lý nó điều kiện lý tưởng lắm đấy. Và chạy xong cho các quản lý chạy cả cái cửa xong nó bị đấy nhá. Nói lòng cái nhiệt cái ấy cái nào mà cái nhóm này tôi cho mỗi em nhóm này tôi cho thực hiện nhá, con cho nhóm khác con nhóm chưa kia được đi làm nhóm khác không ta kêu con Còn nhóm nào muốn nghe giải cái nhóm em thì thế nào, có các nhóm khác nào vẫn đang online hay à? Thì theo em thì là các nhóm khác nào?
lưu cái record vào phát lưu đâu
Không phải lưu, nó tự lưu mà.
Yeah.
Because
thế rồi đi phim nhỉ
lưu.